Hello everyone, welcome to Fun with Stewie. Today we will continue our series on Romhacking. As you know, I'm just a beginner on Romhacking, but I just want to share my love for the subject. And in this series, the idea is to learn about Romhacking, more specifically how to translate a game from Japanese to English, and also to also do it using Python. So learn Python at the same time as we do Romhacking. So it should be fun. In this session, we will mostly focus on how to localize Japanese text in a game. I will be doing my test on Super Robot Wars Alpha 3 on PS2 because PS2 has a nice emulator and debugger. So first, you most of you are mostly used to a text file, like an English text file like this. This is a hello world. And if you want to search for a specific word, you will just use Control F and search for the text directly like this, and it will let you know where the words are localized in the file. Since we PS2 are ISO, first we will first I will show you what files do we have when we extract this ISO. It's called original because it's the original files. When you first look inside an ISO, you will let me find my best friend, zoom it. You will have a bunch of folders and a bunch of files. But if you open any of these files, you see there's no extension txt, and you need to have a special tool to open it. And like all of these will be called binary file because our computer doesn't know what encoding it's using. Encoding is basically how the computer knows that this hello world.txt can be rendered like this. Because computer, as you know, it's always working using bytes. And if we have this hello world text, we can open it using Hex Editor. So I've used HXD, sorry. It's pretty easy to use, it's free. And when you open this file with HXD, so it's very easy to open it. You can just drag and drop like this if you want, and it will open it. In HXD, you will have a section on the left and a section on the right. The decoded text is trying to decode each byte that are here. So these are written using hexadecimal format. I encourage you to look into some videos to learn about it. And the decoded text is actually using the ASCII encoding. So ASCII is the most basic encoding. If we just look inside our ASCII table, like the basic ASCII has 128 characters, and what it does, it does a mapping using 1 byte represented using a X character. So if we look at the character A minus in lowercase, in hexadecimal will be represented using 61. The H in hello world is represented using 68. So if we look here, this is actually it's a H uppercase, so 48. Let's see, H uppercase is here, 48. And so in this case, the encoding that is used in this file is just a basic ASCII. And if I open this using Notepad, Notepad will tell you, Notepad++, at the bottom right, Notepad will tell you it's UTF-8. So UTF-8 is better than ASCII. It can encode more characters, a lot more, and it's more like an extension to ASCII. So UTF-8 can do everything that ASCII do using the same bytes. So it would be the same bytes to encode the H in uppercase. but it will also do a lot more character. So that's why it's UTF-8, and UTF-8 was not, it was invented probably in early 20s, I'm not sure. But yeah, so what happened if you have a file like this and you put Japanese, well, the Japanese character will be encoded using UTF-8 and like this. But the thing is, in the 90s, like 90s, 95, when the SNES and PS1 and PS2 games were invented, Japanese games use another encoding. It's called Shift GIS, and basically what it does, I will show you a Shift GIS table just to show you. It will encode each of the kanji and hiragana using 2 bytes. So 1 byte, 2 bytes. So it needs 2 bytes to encode this kanji. And the thing is, most of the game on SNES, PS1, most of them use ShiftGIS. Sometimes they will use their own encoding. So that's why it's like the computer is not smart enough to recognize how should I open the binary file, the one we just saw. And it's very complex for the computer to know. So if we try to do a small summary, if we want to localize text, we first need to know what encoding the game is using. And the idea is always to use ShiftGIS to try, and we will see. So if I take my game, we'll try to do an example. This is just it's usually when you try to translate a game, you will always start with the menu because menu is always a lot easier to mess with. And yeah, it's a lot easier. So this is the PC SX2 nightly. So you go on PCX6 and you download the nightly release. It will have all the nice features and debug and all of that. And like it takes there's a lot of text going on, but I have a couple of save states here just to show you what kind of text we will be looking for. So if we look at the slot 1, I think it paused. We have some story text here that might be like located in a different file. We have some scrolling text for introduction. We have some objective, and we have menu text, basic menu. Good. So what we can do is, most of you don't know how to read Japanese. So in that case, what you can do is use OCR. Uh, so I will take some screenshot and like let's take these three, okay? Let's see what we can do. I use screenshot to take some screenshot. There are a lot of tools that you can use, and I will use Google Keep. It's one of them, but there are a bunch anyway. It's just that Google Keep lets you do, as you see, I have a couple already for another Robot Wars game. But in Google Keep, you can actually paste an image, and you can grab the text once it's loaded, and it will try to, yeah. So you see, it's right here. You can do some tests to see. So as we said, text in the files will be encoded with maybe ShiftGIS or something else. If we want to search in a file like this, we will need to, let me just open one. So this one, okay. As you the decoded text on the right, as you see, we don't see any Japanese text because this one is done using ASCII, and ASCII does not support Japanese. So it means that we will need to search using hexadecimal bytes. So something we can do is we take our Japanese text here, we go on Shift.js to X, and we have a friendly website, free. You paste your Japanese and it gives you the representation in Shift.js, hexadecimal. So most likely you don't know where in what file the text is, but you know that if the text is encoded using Shift.js, it will look like this. Something we can do is in the debugger. So you go here, open debugger, and you will have a screen like this. There is a memory search. It's pretty useful. You take your series of X, you put it here, you make sure X is checked, array of byte, you hit on search. And, oh, that's a bunch. Okay, the game will tell you everywhere this series of X byte is in memory. Because emulator, like PS1 is also the same, is you have a file on disk. There is a limited amount of things you can bring into memory. And usually the game will load only what it needs into memory, and then to display text on screen, it will read the text from memory. So since we have a lot of stuff in here, we can try to put some 0, 0 at the start and 0, 0 at the end, because we know in Japanese there might be other sentences that will have these three kanji. So let's try this and see if we get a smaller result. It's a lot better. So we have three it, okay? So what we can do with these, we can now inspect this address. So this is an address in hexadecimal. And we can go into memory. So if we double click, I think, yeah, if we double click, it shows us right here the memory, and we see our series is right over here. So something that we can do is we can try to modify these and see if the text updates on the left. So we have two options. Either we update the bytes directly using X, or we can also go on the right. As you see, there's a small dot in green. So if I go and click here, I can actually okay. So what happened? The text is now gone. So let's try something. Let's put the same two values. This would be one kanji. I will just repeat them twice or three times. Okay, so we have confirmed that we can update this text, and the text is localized at this address in memory. So that's interesting. So it would be 4E8. But the problem is, as you saw when I wrote potato, nothing was displayed on the screen. Most likely, the game does not handle ASCII. So, you know, when I put my P, it just updated one letter, and this one, it's using ASCII encoding. And probably the game does not handle this encoding. So we will need to do some things in the future if we want to update this text. But for now, we mostly want to localize text. So we were able to localize the text. It's here, and you see it's very gibberish. So I'll just put it back to maybe like this. Yeah. Okay. This is the text in memory. We saw there are other its that seems to be very close in terms of position. So maybe this text is used in a different menu, and it will have its own text. So it will have three section, maybe three menu. We don't know. So typical rule in PS2 and PS1 game, there is a file. that is always loaded in memory that has a lot of the code, and it's the main executable. On PS2 it's called SLPS. And for a lot of PS2 game, most of the menu text will always be into SLPS. So 4 MB is quite big for SLPS, so there will be a lot of stuff inside this file, mostly code, like MIPS assembly code, and probably text. Okay, so as we said, it's in PS2 game, always look into SLPS if you want to find menu text. So what I will do is I'll just open this with my X file. So let's just my Hex Editor, sorry, just change the extension, and then there you go. So what we can do is we take our series of X, we go on HXD, Control F, X values, search, and we put search direction, let's put all, and if we hit search all, we will have all the hits inside this file. Okay, we see we have quite a few. You see like these, these are probably the reason where we're getting so much hit. It's found in another string. So what we can do, put some 0. Now we have our 3 hit, and it's probably these 3. Okay. One important thing, the SLPS, as I said, this file is always loaded into memory. So it's always available at any time. Depending on the game, it will not be loaded at the same place in memory. So there's like a base address where this file will be loaded, and then it will stay there for all the game. And like if we take this first hit here, okay, this first hit, based on what we see on screen here and here, it's probably the same. You see there are these 3, 4 at the top, so it's probably the exact same string. But this one is address is for is this the 8, the 7 was for the 0. So this address is the 8, and this one address is, we can see actually this one, sorry. The address is 3ECDD8. All right, so we were able to find the address in the SLPS and the address into memory. In our next session, we will try to understand how pointers works to access text into memory, and we will see why we need to understand what are relative pointers. Thanks everyone, and see you next time. Bye bye.